So this question is about the mean value theorem, which I've written down at the bottom. And here's what the mean value theorem says. If f of x is continuous and differentiable, which this is, right, because it's just a polynomial graph. So we know it's going to do something like this. If it's continuous and differentiable on a closed interval, so here we have, let's just pretend like it's -1 and this is +1. I know it won't look like that, but let's pretend like it is. Then there has to be at least one value c. There must be a c, and there could be more than one value c, such that the derivative at c, f prime at c, is equal to the slope of the secant line. So let me explain that a little bit more clearly. Let's say that this, let me redo this. Let me say that 1 is right here. Let's say that this point is 1. If I draw the secant line between these 2 points, that secant line will look like this. Okay. Right? There has to, the mean value theorem says there has to be some point C between those A and B, -1 and -1 and 1, that has the same, or whose tangent line has the same slope. This isn't going to let me draw it in here, so let me draw it just manually. That's what it says. Okay. That's what the mean value theorem says. There's got to be some C right there. So what's the slope of that blue line right there? The slope of that blue line is equal to f prime of c. Right? Remember the definition of derivative? And what's the slope of this line, this secant line? The slope of that secant line is just the rise over the run. Well, this point is b comma f of b, right? And this point is a comma f of a. And what's the slope between those 2 points? It's the rise, which is f of b minus f of a, over the run, which is b minus a. See that? That's the slope formula. See that?
So the mean value theorem is just the slope formula.
The mean value theorem just says there has to be a value between a and b.
I'm leaving.
There has to be a value between a and b that whose tangent line has the same slope as the slope of the secant line between
but
A
to
and
find
B.
your c, you're just using the slope formula, right?
Yeah. So that's what it means. I was just explaining it to you. Now let's actually do this problem. So first the question is, can I use it? And the answer is yes. Okay. So how do I find it? Take the derivative. So f prime of x equals 3x squared minus 2x minus 2. Find f of -1 and find f of 1. So f of -1, remember I'm plugging it into f. F of -1. F of -1 is going to be -1 minus 1 plus 2. Check my math. Did I do that right?
Yeah.
Which equals 0. And f of 1 is going to be 1 minus 1 minus 2, which is -2.
Yeah.
Did I do my math right? So those are my 2 points. Now let's find the slope of that secant line, right? The secant line between the points -1, 0 and 1, -2. You follow what I'm doing? I just pulled these out. There's 1, -2. There's -1, 0.
Yep.
So what's the slope? Rise is -2 minus 0 over run, which is 1 minus -1, which is -2 over +1, which is -2. Check my math, yes?
Wouldn't it be -2 over 2?
Yeah.
Yep, that's why I was saying check my math, because sometimes I do things too quick. Thank you. -2 over +2, which is -1. So that's the slope. So now what I want to do, I'm going to set the derivative equal to that. So 3x squared minus 2x minus 2 equals -1. How do I solve this problem?
You put the 1 on the other side.
I
You
use...
can just factor.
Well,
you set that equal to 0, and then you can factor.
Yeah, I use the zero product property. If it does factor, it looks like it might factor. 3x and x,
And then
-1 and +1. Does that work? It sure does. And now this means that x equals, set each one equal to 0, -1/3, and x equals 1. Now, which one of those is or both of them
They're
are
both, yeah.
inside there.
So both of those are your C values.
Yes, so there happen to be two C values inside there.
Okay.
They don't have to be inside there, but those both happen to be inside there.
Okay.
Got it? So those are your two C values.
And then like just for your like justification, like after, you just say like MVT applies because F is both
Continuous
and differentiable
on the closed interval.
Okay.
Yep. You say, if the question was, can you apply MVT? You say yes, because
Okay.
the value is continuous and differentiable on the closed interval. That's exactly what you do.